Welcome to the next video. I'm doing simplifying radicals again, but we're including variables this time. So it's going to be a little different, but also at the same time might be a little better. So let's get you there. So we're being good. We're still going to use that same little table we got down a few weeks ago when we first started these square roots, and we still get to be useful for us. So what if you're asked to find square root of 24x? Okay, so what you first want to do is look at the number and see, all right, what are the factors of 24 that I also see there on the left side of my screen? And then you go, oh, well, 4 works, right? Because 4 times 6 gives me 24. So it's going to be 4 times 6. Technically, there's x, right? But we can't really do much about that. And technically, they're all being multiplied times each other. So what you do is split them up. So it's going to be root 4 times root 6 times root x. We see there on the left side of my screen that you can replace the 4 with 2 squared, root 6 and root x. Nothing to replace them with because we don't see them on that side. And what you do is square cancel square root. So we're going to have 2 in the front. And we can't really reduce the root 6 or root x, right? So just put them back together. And that's your final answer, actually. So 2 times square root of 6x. All right. Let's try another one. What if trying to simplify 24x squared? Okay. So we're square cancel square root. But first I'm going to start with the 24 again. So as we know, 4 times 6 is 24. And then we still also have, x squared going on, which is nice too. So let's split them apart. So root 4 times root 6 times root x squared. Then we can replace, the only one we can replace is the number. So we replace the 4 with x, or with, 2 squared. All right. So remember at this point, square cancels square root. So square cancel square root. We have 2. Look at that. We have a square here and another square root. So those actually cancel. So we still have an x. So that gets to be brought out front too. And what's left is this guy because we cannot cancel anything else. So that's our final answer. Okay. So basically we're looking for a squared value of the variable in order to cancel and bring it out front. All right. Next one. What if we had to do 16a? All right. Well, 16. Well, we already kind of know that one, right? Because we already see that here on the far side of our screen there. It's basically, all right, that is actually already a perfect square. So I'm just going to go ahead and split it already. Root 16 and root a. The 16 can replace with 4 squared. Root a can't modify at all. That's okay. So then the square cancels square root. And we can't do anything to that root a, so it stays as is. All right, there we go. You're doing good. How about root of 32 into the 3? All right, so we got a few pieces going on. Let's first worry about the number. So biggest number that's less than 32, that is awesome. A factor of 32, 16. So we're going to have 16 times, well, no, there he goes, times 2 is 32. And we're kind of looking for things that are squares. So remember, inside of n to the 3, that means there's 3 n's. So we're going to split it up into n squared times n. All right, so let's see what we can do with that. So they all get split apart. 2 root n squared and root n. Now let's see what cancels, huh? Oh, I forgot, and then we get to replace. Sorry, I forgot to replace the 16 with 4 squared. Still have the 2 n squared and the n. All right, so now we can cancel stuff. So square cancels square root. So we got a 4. The other chance we see a square there and square root. So let's cancel out. We got an n comes out front. What's left underneath the root sign is the square root of 2 and square root of n. So it starts off with that, correct? Square root of 2, square root of n, and you can basically just condense them back together. It gets 4n times root 2n. And there we go, guys. Good job. Got a couple more examples. See, how about, oh yeah, big old number, 150 n to the fourth. Big old giant thing. All right. So what we're going to do, look for the biggest number that's also a factor of 150 there. I think I'll stick 25. So at least for numbers wise, 25 times 6. Okay, so 25 times 6 gives me 150. And into the 4, there's 4 ends. Technically I'm trying to look for to make them be squares each. So what we can do is separate them out to n squared times n squared. Because if you multiply them back together, that puts you back into the 4. But I'm just going to keep on rolling and separate them all out. So 25, 6, n squared, n squared. Oops, that's not n squared, is it? N squared. And what I can do is I can replace the 25 with, we'll do it right here actually, with 5 squared. So that's the only thing I'm changing right now. Okay. Now I can cancel things out. So we're going to square, cancel square root. So we're going to have 5. Then square, cancel square root. Means we're going to have an n. So basically 5 times n square root times another n. And what's left under a root is just that root 6. So all that times each other. So when you collapse them all back down, 5 times n gives you 5n squared times root 6. And there's your final answer. All right. Hopefully it's starting to help out pretty good. Our last one. What if we had root of 16b to the 3? Ooh, okay. So kind of same style. Or what if we did a little different? We saw 16 before. What if we go, oh, I see a 4 on there. It's also a factor of 16. So it's going to be 4 times 4 gives me 16. And we're looking for squared. So I'm going to break out the v squared times v to break out the v3. So it's v squared times v. And now separate them all out. Root 4 times root 4. Root v2 times root v. Replace the 4s with 2 squareds. And everything else staying the same. Now we can cancel and see what is left. Square and square root. So we got 2 times 2. Cancel. So it's going to be 2 times 2. Square times square root. Cancel times v. And that's all still, these are all still multiplying times each other. Now let's collapse them back all down. So 2 times 2 is 4 times v. So it just equals 4v times square root of v. There's your final weird little looking answer, but that's it. Good job, guys. Let me know if you have any questions, and we'll do just fine. You got this.